So in this session, we are going to introduce you how we use Splunk and our premium apps, ITSI and VictorOps, to accelerate our DevOps lifecycle. So my name is Scott Lu. I'm from the Splunk Shanghai office. So my area of focus is front-end testing and framework. I'm also joined with my colleague, Alfie. Alfie is an engineer for the reporting services. Skip this. This is today's agenda. I'm going to introduce you a little bit about the DevOps lifecycle in Splunk. And then I'm going to introduce you two applications. One is called ARTS, Automation Triage, Result Triage System. And the other one is InfraWatch. Basically, it monitors our whole CI/CD systems. And then I'll leave some time for Q&A. However, if you guys have any question, feel free to let me know. Okay, so this is a very typical CI/CD loop. I believe most of the companies are using the same ways of define their CI/CD process. So it goes from planning to coding, development, and then have a ready build to continuous testing, including unit test, functional test, system test, as well as performance test. And then it goes to release and deploy, operate, and monitoring. So in each one of the states, we have our own tools to monitor the status of the states. But today, we're only going to introduce you two of them. One is ARTS, and the other one is InfraWatch. Okay, so ARTS, again, it stands for Automation Result Triage System. So it is a application built by the team in Shanghai to help the triage engineer to fast triage the test result and take actions upon it. So before we have this application, it takes quite a bit of time for us to do the triage. Usually it takes about 3 days or even a week. So with this application deployed, we were able to reduce the time to a day, a half a day, or even just hours. So why did this application help us to accelerate the triage work? So let's go back to the original problem that we were facing. This is a very typical CI workflow. We have a Bitbucket, we have a pull request open in order to be merged. However, before we do that, we need to get the testing running and passing, right? So we send a pull request to Jenkins, and Jenkins will schedule a job to run the test against this pull request. And then we chose AWS, VMware, and the Docker image to be our infrastructure. However, when the scale comes up, we have a lot of pull requests raised every day. So we have to open up multiple Jenkins CI system in order to incorporate those requests. So the first problem comes. There are just too many Jenkins jobs and too much Jenkins data to look at. So this screenshot tells you like how many Jenkins jobs do we have. This is just a very minimal. We have more than this many Jenkins jobs to look at each day. So you can imagine how much pressure that each one of the engineers, especially the triage engineers, facing. And then the second problem. So we think Jenkins is not very intuitive, and the UI is not very user-friendly, you can say. So why don't we just store the data to somewhere? The first idea we came up with is to store the data to conference page. And then the problem comes up again. We have build running every day, every hour, every second. So the conference page is not going to scale. We have multiple conference pages to store the same data, different builds. However, the data is just too much to be charged. So every day you can see the column keeps increasing with the build number. It's not going to scale for each one of the triage engineer. And then the third problem is, even though we have this data in our conference page, we cannot take actions upon the the result. So if we say, hey, we triage the test result, the test failure is due to blah, blah, one product bug, how are we going to communicate this to other engineers so that they can take actions upon it? We cannot do that with conference. So there comes with our solution. So why don't we just use Splunk? We say we are a Splunk company, and why don't we just leverage the powerful Splunk search? So we index all the data from Jenkins server to Splunk. And also we index the Bitbucket data, AWS data, Docker image data, and the VMware data all together into Splunk for further investigation. And in addition to this, Splunk has this very cool addition ability to connect to other software, such as Slack, email system, Jira system, everything is connected. That's basically ARTS. And this is a very typical CI workflow in Splunk. So we go from Bitbucket, Chaperon to ARTS, and then Jenkins, Slack, and documentation. So ARTS plays a very critical role in this workflow. It kind of connects the two sides. One is the code side, the other is our action side. Okay, so that's about the background of ARTS. And then the next stage, I'm going to introduce you some of the basic functionalities that ARTS provide. The first one is the overview page. It encapsulates the basic information from each one of the Jenkins runs. So as you can see from this screenshot, to the left it is the Linux job, and to the right it is the Windows job. So the number in bold, it's the test failure, and then the number next to it in gray, it's the total test cases. We use single value because we want to compare to the previous run. And the trend line below, the whole idea is to show the last 7 days, what's the status, what's the history of the test run. The one to the right is highlighted in yellow because we can set threshold on each one of the test run. So for example, we can set if the test failure is over 150, we alert our engineer. The next one is our trend page. Trend page is a little bit more advanced to the overview page. It gives you a little bit more information. The first row gives you the total test cases, how many tests have failed, what's the pass rate, and how many test cases has been skipped. The second row, it automatically categorizes the failures into different categories. For example, the product bug, infrastructure issues, flakiness, and also test failures. For example, each one of the panel can be drilled down. It's an in-page drill down. You can click on it, and it will show the detail of the failed test cases. Also, it connects to the Jira system. So if the test failure is associated with one of the Jira tickets, then it can be shown on this table. Of course, you can click on the Jira ticket to get more information. It will directly connect you to the Jira system. Next, branch compare page. So oftentimes, the engineers, when they want to merge their code to the developer branch, they need to make sure the code is with good quality, right? So how are we going to determine that? We use this branch compare page. To the left, it is the pull request that the developer has raised. To the right is the benchmark of the developer branch. So you want to compare if your code is good enough. So only when there is no regression, no feature bug, so that you can merge your code. Last but not least, the triage notes page. It enables the engineer to be able to put on the notes on each one of the failures so that it can be broadcasted to other engineers so that there's no duplication of the work. You can associate with words, with SPL, which is the Jira ticket, and other ones can just see it after you update this triage node. Okay, so that's enough for the introduction. I'm going to give you guys a live demo. Let me switch this. Okay, so this is the overview page that I was talking about. It gives you a very brief introduction of the whole status of the Jenkins server. So in the first row, it is the front-end testing with the browser information. The second row, it is the back-end case with which testing the REST APIs. Click on the number. It will bring you to the trend page. I have already loaded so that it saves time. So this page is enabled with dark mode. We just released it this October so that you can have this on your big screen. Okay? So this one gives you a little bit more information, right? So the total test cases, total failures, and as I said, you can click on the panel to see more details. So if I click on the product failures, it will bring you to the list of the failures. These are the 34 failures. And each one of the failures are associated with the number, the JIRA ticket, so that the JIRA ticket will be automatically populated in this table. And if you want to see the details, you can just click on the JIRA ticket, and it will bring you to the JIRA system. Everything is connected in this one application. You don't need to go to different systems. It saves a lot of time. And then the next demo I want to show you is how we use it for our daily work. So first of all, this engineer raises this pull request, and he wants to know if the pull request is good to go. So once the pull request is raised, it will be triggering some of the Jenkins job, and the Jenkins job will return the test result. Right? For example, this one, it got 8 failures on the front-end testing. We want to take a look at why it failed. So this link gives you the target branch comparison. I already loaded here. So the benchmark got 0 test failures. However, my job got 8 test failures. What happened? I want to look at it. So I click on the regression testing. I say, okay, these 4 test cases failed. Why? I click on it again. It will give you the stack trace of the test failure. All the data are coming from Jenkins server. I can show more. This is the stack trace. I see, oh, there's an assertion error. Maybe it's caused by some of the product bug, right? So I want to give this note to other engineers. I would say SPL 1, 2, 3, 4, 5. Just assume it is, and save it, and it will be automatically uploaded to the system. Yeah. Okay, so all set. We have already triaged the test result in just a couple of minutes instead of going to different systems. Okay, that's basically the demo. Let me switch back. Also, we provide some of the beta functions. The first one is flakiness detection. We know that in the QA domain, we all hate flakiness. So we provide this page to help our engineers to detect if a case is flaky based on the historical data. So this page has a very nice dashboard to help you to identify if the test case is flaky or not. And then the second one, we call it predictive triage. So we leverage the machine learning toolkit as well as our arts so that we can predictively give you a triage note based on data. So we already showed the triage note page. This is an advanced one with a machine learning toolkit enabled so that once you open the triage note, it will predict the test failures with the corresponding JIRA ticket based on the historical data. Of course, it's your choice to accept the JIRA ticket, the recommended triage note, or you can just use your own judgment. Okay, so let me give a little bit summarize of the benefits that ARTS has provided. First of all, it's fully automated. All the data coming from Jenkins is automatically indexed into the Splunk system. Second one, it's a faster response time. So imagine that without this application, we have to open up different multiple browsers on Jenkins, Jira, whatever system that you are using. However, with Arts, everything is in one page so that it saves a lot of time, especially for the triage engineers. The third one is a connected experience. So as you can see, all the systems are connected together. Jenkins, Slack channel, email system, Jira, and a conference page. Everything is within this Arts application so that you don't need to go to other places, and it saves a lot of time. With that, I'm going to introduce Alfie to talk about the next project.
Okay, thanks, Scott, and good afternoon, everyone. And thanks very much for joining us in this afternoon. My name is Alfie Yu, and now I'm going to introduce you about the monitoring system we built for Splunk internal CI/CD infrastructure. We call it InfraWatch Project. The system is based on Splunk ITSI and VictorOps. So first of all, let me introduce what kind of problem we want to solve with this monitoring and alerting system. So my department maintains the CI/CD infrastructure of the company. So the most important task of the department is to make sure the infrastructure as stable as possible. Because if only the infrastructure let the CI pipelines of the product team can be finished efficiently and correctly, then that will shorten their DevOps lifecycle and increase their productivity. So in our infrastructure, we have a lot of services and tools. For example, we use Bitbucket for code as a code repo, Jira system for sprint planning. We use Jenkins to manage our CI pipelines, and our tests are executed in Docker UCP environment. And also, we developed many internal tools to fulfill needs from product team. Technologies we use include Nginx, Kong, Redis, and several databases. So there are two critical requirements we need to meet with this monitoring system. The first one is, with so many sys services and tools we want to monitor, we need to have a unified and manageable monitoring system. Can you imagine each of these services or tools have their separate monitoring system? That would be a nightmare of operation guys. And the other requirements is we want to respond fast. Anytime an incident happens in this infrastructure, we want to have some on-call engineers respond to it. To achieve that, we could define SLAs for operation, but to make it executable, we need a unified and efficient alert or incident management system. So our solution is to use Splunk ITSI to build the monitoring system for all those services and integrate it with VictorOps for the alert, to send alert notification and also the incident management. So this is an overview of our project. In the bottom layer are the services we want to monitor. And in the layer above, we use four different methods to collect data from these services. And on the top layer, we use Splunk ITSI and several dependent applications to monitor the system, and all the detected incidents are sent into VictorOps. VictorOps will send alert notification to on-call engineers and manage incident status. So before we dive into how to set up this monitoring system, let's look at what we are monitoring. This page displays all the services under monitoring in our system. It's a tool provided by Splunk ITSI. In this map, each node represents a service under monitoring. So you can see that we have multiple instances of Jenkins, multiple instances of UCP clusters, and Artifactory, and Bitbucket. And recently, we also added monitoring for our Kubernetes cluster. So there are also dependencies between services. For example, you can see to a UCP service, it depends on a UCP worker service and a UCP manager service. Okay. Besides these real services, we also define several abstract services. For example, we have a unified Jenkins service which represents all the Jenkins instances we have. And at the top level, we have a Splunk CI/CD service which represents the whole infrastructure of our CI/CD platform. So you can tell health status of the service by color of the node. So green stands for health, and yellow or red stands for some incident is happening in the system. And the dependency between the services represent the impact of the service. For example, you can see that we have a UCP worker service is in red color, which means some incident is happening, right? So it impacts the UCP cluster it belongs to, and also the abstract UCP service, and also the Splunk CI/CD service. In practice, usually we utilize this kind of dependency from top to bottom. So when we see something is happening in Splunk ITSI service, then it will help us to drill down which part of the infrastructure is in trouble. Okay, now let's look at how to set up this kind of system. So the first thing is to collect data from all those services into Splunk. So from the picture, you can see that we have 4 different methods to collect the data. 3 of them are implemented by installing agents on the target host. So we use Splunk Forwarder to collect data from log files. And we use collectd is used to collect metrics from target hosts, like CPU usage, memory usage, or information from processes. And we also have some custom agents installed on the host, including some Splunk add-ons. For example, Splunk Connect for Kubernetes to collect the data from the Kubernetes cluster. And we also implemented some internal cron jobs to extract data from those services periodically. Besides that, the 4th way of the data collection is implemented as a separate service. We call it API props. So it props on the API of all those services periodically from a user's perspective and confirm whether the service is working properly. For example, to the Artifactory service, our probe will do some file uploading, downloading, and deletion, and store the result of the operation into Splunk. One advantage of this kind of probe is it can find the problem even our system is in idle status. For example, in the midnight, the system is not in use, but we can still find the problem in the system and fix it before users really experience problem with it. So all the data comes into Splunk via HEC. With the data collected in Splunk, the next step is to implement the data model for these services in ITSI. ITSI leverages the data model of service, entity, and KPI. So service stands for a target with health status to measure. For example, it could be a real service, like a database service. It could also be an abstract service. Like I mentioned, we have a Jenkins instance to represent all health status of the Jenkins instance we have, and a CI/CD service to represent the whole infrastructure. And entities are components inside the service. For example, we have a database service, and it's deployed on several machines. Then each host can be defined as an entity in ITSI. So entity must belong to a service, but a service may not have any entity. And the last one, KPI is a metric which could reflect health status of the service or entity. We define threshold on it. For example, CPU usage, memory usage, or count of errors we found in log files. So in the picture on the left side, the data model example we set up for Artifactory service. So we define the service, ITSI service for the Artifactory, and this service has two entities. One is the application server. The other is the database server. So entities could have some KPIs in common, for example, CPU usage, memory usage. But each entity could have specific KPIs for themselves. For example, to the application server entity, we have KPI for count of thread. And for the database, we have KPI for count of DB connection errors. And also, we define some service level KPIs, like response time of the Artifactory API and the count of response errors from this API. So with all these KPIs defined, the last step, but its critical step, is to define health score of the service. Health score is calculated based on the weighted KPIs. So we should assign different weights to the KPIs depending on how the KPI is critical to the service. And the maximum value of the health score is 100, which means the service is in 100% health status. But if the number goes down to below 100, which means some KPI in this service goes wrong and need to be checked at. Okay, with the data model set up, now we can start to monitor this system in ITSI. This tool is named Service Analyzer, provided by Splunk, provided by ITSI. It displays the current status of health score and the status of all APIs of this service. You can tell status of whether the KPI is in good shape or not by color. So for example, in this case, my memory usage of the service seems to have some problem. I can just click on the icon, and it will drill down to the entity level. So on the right side, you can see it lists current KPI status of every node. So I can figure out which node is causing the problem. And if there's any incident happens on this service, it will be also listed out in the central column at the bottom. I will come to the incident later. So with Service Analyzer, it will help us to narrow down the scope of the analysis efficiently. With Service Analyzer, it displays health status of our service, but usually there are more service status we care about. For example, our traffic volume of the service or user behaviors, we want to see all this information. So we define or customize glass tables for each of the service we monitor and displays all the information we care about in the same screen. So this example is a glass table for Artifactory. So in the central line, these are the health status of services and entities and some critical KPIs. The row on the top is about traffic volume, like upload volume, download volume, or Artifactory service. And the bottom row is about different metrics of different user scenarios, such as the usage of NPM or usage of .registry. And there's also a red frame on the right side. It's about some critical errors we want to pay attention to about Artifactory. So the glass table is very cool, right? You can see all the information just in one screen. It's very efficient. But what if I want to see more details? For example, if I see some metrics may go wrong, I want to check further. So the solution is we can set drill down links on every icon on this glass table. For example, if I want to check on the artifactory errors, I can click on the icon in the errors frame, and it will show me the dashboard of artifactory issues. If I want to see how users are using our artifactory service, I can just click on the icon, click on the widgets at the bottom. It will show me the user request analysis dashboard. And if I want to know upload and download volume details, it will open a dashboard of artifactory usage analysis dashboard. So it's very convenient and make our dashboards more organized. Okay, the last step on Splunk ITSI side is to define some incidents or alert for our systems. So the incident could be triggered either by predefined KPIs. So as you can see in the picture, I define some threshold for the KPI. So once the KPI hits the threshold, it will generate an incident. Or the incident could be generated by some ad hoc SPL, just like we define some basic errors in Splunk. But this incident won't generate any alert by default, since we want to avoid sending a lot of alert messages to operation guys. That will be a noise. So we use another tool provided by ITSI named aggregation policy. It provides very flexible rules for us to aggregation these incidents and only generate alerts on the episode level. So there's also a tool named episode views. So you can see the impact of this episode. For example, the impacted services or impacted entities of this episode. And you can also see all the event details in this episode. So finally, Splunk ITSI sent an alert into VictorOps. VictorOps provide both mobile app and web UI. So after operation on-call engineer receives the alert notification, he can choose the either way to respond to it. Here I listed several VictorOps features helpful to us. The first one is the incident management. So the on-call engineer can set status of this incident as acknowledged or resolved. So other team members can understand who is taking care of this incident and what's the progress of it. And another feature is named on-call schedule. So we use this to configure on-call schedule for every team members. So VictorOps will send an alert according to the timestamp of the incident happens to the on-call engineers. And the last one I want to mention is about escalation policy. So once the on-call engineer cannot respond to this incident in time, VictorOps will, based on this policy, will escalate the alert notification and find the backup engineers. Okay, at last, I'd like to summarize what kind of benefits we can get from this monitoring and alerting system. So the first one is, with this centralized monitoring alerting system, it reduces the complexity of our operation work dramatically. Especially in our case, we have so many systems to manage, to monitor, and to operate. The second thing is, with Splunk ITSI, I can set up this monitoring solution pretty easy. So the first step is to collect the data from this service, and the second step is to define data models for it. And the last one I want to mention is this Splunk plus VictorOps solution makes our operation work much more efficient. With those tools or features I mentioned in ITSI, it can help our operation engineer, on-call engineers to triage on the problem efficiently. And also with the help of VictorOps, we can make sure that every incident could be responded in time and finally meet our SLA. So yeah, so that's about my introduction about this project. Thank you. So, hi. What's the question?
Data injection.
Mm-hmm.
Data ingestion.
Sorry, I can.
How much data ingestion is required for all this?
Yeah.
That depends. So it's not the one night work. Since we at first we define some KPI, figure out some KPIs we care about, and we start to collect data around these KPIs. But maybe later we find we didn't cover some case and we miss some data, then we'll add more data ingestion.
Total.
You mean volume?
Yeah. No.
No.
I don't think that.
Yeah.
Yeah.
A few gigabytes.
Yeah.
Thank you.
Yeah. Question. I think it's fine, just raise a question. We can hear. Yeah.
So I noticed in ARCS, you had a field where you could type notes.
Yes.
That was really nice.
Yeah.
How did you do that? Did you just do that like as a table or as a lookup within Splunk? And then how did you associate that with each triage event?
Yeah, very good question. So we actually leveraged the Splunk feature called tags. So if you look at the tags feature of Splunk, it's essentially the same. So we use this and we tag each one of the test cases, test failures, with the triage nodes. So it's kind of like a KV store to store the information about the tags and the test cases. So it's a one-to-one mapping.
And then how do you, like, what's the, how do you track each triage? It's almost like I'm thinking of a database that's specifically that ties to triage. How do you create those? You know, because I'm assuming you're associating those nodes with that event.
Mm-hmm.
So do you have like an event number for each of those events, and how do you create that?
No, actually, it is as I said, it's a KV store. So basically, it's not that advanced, I would say. But in the next version, we're trying to provide this kind of what we call the rich tag. So we will have some more details about each one of the event. It's if you want to say it's similar to notable event in enterprise security. So we are working on this. But right now, it's just a KV store, a KV pair stored inside the Splunk.
Nice. Thank you.
Yeah. Any other questions?
So in one of your in one of your diagrams, you had 3 different ways of collecting the information and throwing it into Splunk. The one I'm thinking about is the custom one. So in what instances did you require the custom collector or whatever instead of you doing something within the forwarder?
Yeah. A very good question as well. So basically, we have, for each one of the system, we have this kind of plugin. For example, Jenkins, we have a Jenkins plugin, Splunk Jenkins plugin, so that it will transfer the data from Jenkins server to the Splunk. And you can actually configure it, like what kind of fields, what kind of data you want to index. Because Jenkins data is huge, right? You don't want to index all of them, but you can select. Same thing goes for UCP and other systems. So we all have these kind of connectors.
Okay, so that's how you're able to reduce the size of your ingestion then.
Yeah,
so if you pull in all the logs, it's going to be
it's all
huge.
configurable. Yeah. Question.
So do you have plugins for other CI systems like now you have showed for Jenkins, but you have like for Concourse? If not, how we can put right now actually, so we don't have kind of metrics for Concourse CI. into Splunk. So I built like custom backend,
Okay.
and I'm using Heck endpoint to dump those metrics. But if we have any integration with the CI.
I'm not too sure about that because I need to check if we already have that. But you can definitely build your own. I mean, it's open source, right? So the Splunk plugin for Jenkins is open source, so you can contribute to that. Any other systems, if you don't find an existing Splunk plugin, you can just always create your own. Yeah.
Okay.
Yeah, so you see an application for using Splunk for a Jira environment. Since you're using Scrum, you have sprints, backlogs, sprint backlogs within Jira. Do you see any type of velocity tracking that we can utilize with Splunk?
Right now, we don't analyze data from Jira. We only connect to it. We use REST API call to the Jira system and fetch the data into Splunk. We just show it, but we haven't gone to the stage where we analyze the data from Jira. We could do that, yeah, definitely. Yeah. Yeah, that's a very good use case, I would say.
So a couple of questions from InfraWatch Project. So in the InfraWatch Project, what is your team's responsibility? I understand build, deploy, but underlying infrastructure, whether it's up or running, or APIs which come up, monitoring those APIs, is that responsibility of your team as well?
Yeah, so the team set up this ITSI environment and do the set up the monitoring, for example, class tables, set up the data model for each service we want monitoring, and also integrate with VictorOps, configure those incident alerts, those alert actions to VictorOps. So all these kind of things I just mentioned in my slides. So, and our operation team may take care of these kind of actions, real actions.
So operations team is separate from your team?
Some of them, yeah.
Okay.
But we works closely.
One last question. The Jenkins infrastructure, is that running in Kubernetes?
No, Jenkins is host, on-prem host.
Okay, thanks.
Thank you. Any other questions? No? All right. Thank you, guys.
Thank you very much.